Here's problem 2913. A wire mass 50 grams, length 40 centimeters is suspended horizontally by two vertical wires which conduct a current of 8 amps as shown in the figure. The magnetic field in the region into the paper has a magnitude of 60 millitesla. What is the tension in each wire? So as far as our wire is concerned, our conducting wire, we have a current going this way. Value of the current is 8 amps. And the length of this wire segment is 40 centimeters. So this length here is going to be 0.4 meters. And the mass is 50 grams, which would be 0.05 kilograms. Okay? There's a magnetic field that is into the page, and the value of that magnetic field is 60 millitesla. So if we look at this wire segment and the magnetic field using the right-hand rule, pointing in the direction of the current and then closing on the direction of the magnetic field into the page, my thumb points down. So there's going to be a magnetic force on this segment that's going down like this. And that will combine with the weight force, which is mg, also going down like that. If I look at the segment on the left with the current going up, as indicated, then using the right-hand rule, there will be a force going to the left like this, a magnetic force. It's called F1. And the segment on the right with the current going down as indicated, there will be a force F2 like this. Those two forces will cancel out on this whole system, and it's not going to matter. We're interested only in what's happening to the segment down below. But there will be a tension force along this string here, and a tension force along this vertical wire here. And by symmetry, the value of those tensions will be the same. I mean, we could look at this thing from the back side, and there'd be no difference between either side. So we're going to have the same tension for both of those values. Alright, so from a free body diagram standpoint, the sum of all the forces in the y direction should be 0, and we would have 2 times the tension minus this magnetic force minus the weight force. So looking at this, we would have that 2 times the tension is going to equal the magnetic force plus the weight force. So let's kind of say that for the moment. Now the magnetic force is going to equal the current times the length times the magnetic field times the sine of the angle between the two. And that is going to be the current times the length, magnetic field times the sine of 90 degrees, which is going to be 1. So we have that is equal to 8 amps times the length, which is 0.4 meters, times the magnetic field, which is 60 millitesla, and this is equal to 0.192 newtons. So that's the magnetic force. The weight force is mg, and that's going to be equal to the mass, which is 0.05 kilograms times 9.8, and that is equal to 0.49 newtons. So we have 2 times the tension equals the magnetic force plus the weight force, and that is equal to 0.192 plus 0.49, and that's equal to 0.682. So the tension is going to be equal to 0.682 divided by 2 as we solve this. So that's going to be 0.391 newtons. So that is the tension in either cord, 0.391 newtons. Oops, 0.341 newtons. 8 divided by 2 is 4. So 0.341 newtons is our answer.